Hi friends, now we will see some advanced topics in our advanced Python course. Now we will see the Numpy. Numpy is just a core library that is written in C++, and we can say this is the top few layers for user interface that is in Python, and the rest is all pre-compiled libraries. So this is how Python platform makes up for its speed. That NumPy is the core library for some scientific computation in Python. So we can say NumPy is general purpose array processing package also, right? That provides a high performance, can say multi-dimensional array object and lots of tools for working with these arrays, right? And if we can take one example, we have a matrix. Whenever we create matrix or perform any task of matrix, so this library comes in handy. So let's see how it works. Basically, we import NumPy library as NP. As I said that NP is just an alias for using that library in our course. Now I have a list and we want to know what is the type of that list. So basically we use we call this function called as type, and we see the type of this is list. Okay, now we have is instance. So what basically is instance is it returns whether we are passing two values and that is true or false. Basically it returns only true and false value. So let's say first what I'll do is I'll give a float value. Okay, but I want to know that is 1.2 is an integer value. No, it is not. So definitely it will return false, right? But whenever I want to know the exact value, then it will give the answer, yeah, it is of int type or float type, so it also comes very handy. Now what I'm doing is let's print that my list. Okay, so what we do is can see that we have defined one list. Now we are converting that list into an NP array, that is NumPy array. Okay, so in this way this list can be converted into NumPy. All right, now we can perform on all the numerical Python operation or with this matrix value. Okay, this is basically in terms of matrix, right? And here again the type is converted into NumPy ND array. Okay, so let's see what is the type of our n1, that is integer 32. Okay, so just because we have 5 element here and each element takes 4 byte, right? So this is how it becomes 32 bytes, or we can say int 32, right? If I see the exact item size, that is one item size, that is 4 byte. Okay, now what we are doing is we have a list and we are printing the type of that list, and again we have another list which is nothing but our NP array list. Okay, and we'll see the type of that list. So this is our first list, that is list of this type. Then we are printing n1. Okay, here n1 has become our array, that is ND array, right? And we are again printing type of n1. Okay, so what is the type of n1? That is ND array. Now it is giving us the dimensional, that is ndim. So ndim basically returns the dimension of this array list. Okay, so it has become 1, and now the size, item size of this is 8. Why 8? Just because we have a float value here. Okay, now it has considered this as a float, so each item size would be 4 byte here, right? This is float 64. All right, so this way we calculate the size. So let's see, we have some more operation here. We have defined again one list. Okay, and we are passing that list into our array and we defining the data type itself, right? So let's see what happens here. We have printed our list first, that is here. So this has printed our list as the type of list, and now we are printing that np array. Okay, so here the list is converted into the array, but how? So first argument this takes as a list, then we are defining the data type. Okay, so data type we are providing np of int 8, right? So it all the size of each item will get converted now. So since we have how much value, 1 2 4 5, okay, so it has converted the size of each element also. So we have one dimension and np dot item size is 1 now, right? Because that is how it will give us 8 byte. Okay, basically are here we can say we are forcing the data type, right? Or we can say we are forcing this to our array that change this data type forcefully. Okay, so that is why now each item size is 1 byte, or we can say just 8 bit. Okay, so generally it is recommended that we should not change the data type like this. Okay, because we should let numpy decide based on the data type or on the compatibility. Okay, so this is what numpy provides us. Now let's see, we are again importing that numpy and we have one more list, that is list 2. Here probably we are passing this list with comma separated. This is one list inside a list, another list, another list. So this is basically we are designing a matrix, that is a 3 by 4 list. Okay, here it is normally 3 by 4 list, right? Or we can say these are sub list to represent a row. Here we just normally print that list and the type of list, right? It is, let's see what it gives, and then we converting this list into that array. Okay, now it has become a 3 by 4 array. Let's see, in first statement it has printed that, then we got the type list, and now we have converted this list into a 3 by 4 what array. So here we have 3 row and 4 columns, that is row into columns. Okay, so this way we'll get this, and this is simply the n34, that is n3 by 4 is our two-dimensional array. Okay, now it has become, and we have shape is 3 by 4. We have size, the size is total number of elements, that is 12. We have data type, so the data type of this array is now integer, and the item size, each item size is again 4 byte. So next here what we are doing is we are again giving a range. Okay, that is a range which is 0 from 9, right? And we are printing this a range. Okay, and then we are checking the shape of this a range list. Okay, so it basically gives us this shape, that is since it is 1D format, so it will just return the shape, that is 10 is the number of elements. So generally here sometimes what happens is numpy range aspects floating point, but python range does not. Okay, so we can say that. And now we have a fact here, that is numpy range accepts floating point, but python range never do that. Like here what we are doing is we are taking a range, but now it is in float points. Okay, so it will normally accepts this and will tell the shape and return the range values. Okay, but if we do normally in or python, so that will not accept this floating point and return the no their range, like range in normal integer. So here again, what we are doing is we have now n6, that is a range of 6 elements, and we are printing all those elements and the shape. So this is as we just discussed. So now let's see, we have some two-dimensional array also. So how we can work on that? We are basically taking a variable and 2 3, that is 2 by 3 matrix, and here we are giving a range from 0 to 5, okay, and reshaping this range value from 2 multiplied by 3, okay. So now what we are doing is we are printing that and getting the shape. So here you can see that we got 2 rows and 3 columns, that has become our 2 by 3 matrix. And here the simple thing is, if we have number of element like 6, okay, 6 shape elements, then we have to factor that value, like we are passing here reshape, so reshape should be a factor of this 6, okay, as it is 2 by 3, could be a 3 by 2, which is feasible. But what if I am giving something, some number that is not a factor of 6, so it will populate an error, which is obviously because it will factor that into a shape. So here what we are doing is, again we are taking a n2 by 3 matrix and the shape is 6. Now we are reshaping it by 3 and we are passing -1 here, okay. So basically what happened, if we have number of element as 6, right, and we have to factor that, but it can't be 2 by 1 or 2 by 4 as I discussed. But what if I have 3 and I have given -1? So what it will do is, what happens here is, we know total number of element is 6, right, and we pass on dimension to be 3 rows, okay, this is a row, and the other dimension we don't want to calculate, like let numpy decide that what should be the other dimension with respect to those elements, okay. So here numpy will simply do that for us and give us it with 3 by 2, and we have to pass the other dimension as a negative value if we don't want to know column dimension. So we can give any number in negative, so it will always do that for us. So what if I want to give the row only? So it could be like this, if I don't want to calculate the row but I want the column should be calculated, so I can again do in this way also, okay. So next we have a seed function. We can say these are some pseudo random numbers. If we use seed, so we will always get same values, like whenever we are giving a random thing or right, so if we pass the seed function in that, so it will always generate the same values at as it will give as first time. Let's see, we are using random from numpy, and that is range number in integer, okay. So the lower value is 10 and the higher value is 100, okay. So and the size is 12. Now what will happen is it will generate values from 10 to 100, and every time it will return the different values, okay. But what if we are using seed, okay. So let's say what if I uncomment this, so it has given 44 to 25 at last, again it will give same values as much as the time I want to run this code, okay. And let's say if I want to generate values from 10 to 100, but the size should be 3 cross 4, okay. So it will give us into matrix, so I can do either ways. Now we have 2D split. So basically what happens whenever again we want to split to two-dimensional data, so how we can do is, let's say we have some random values from 10 to 100 and we want to split it from 6 to 8, I mean that is a 6 by 8 matrix, right? So we will get this 6 by 8 matrix. And now in 2D split we have horizontally split and vertically split functions. So how we can use them? First we have H split, or we can say head split or horizontally split. What it will do is it will split an array into multiple sub array but horizontally, like column wise, and split them with axis 1 in other way. So it has splitted all those 6 by 8 matrix into 4 different matrices, right? And we can also use that by using for loop, so it will return all those matrices separate. Okay, let's say we want to split our that matrix 6 by 8 matrix into one array. So again it has splitted that with a single matrix. But what if we want to split them vertically, not horizontally? So we simply use that v split. Okay, so v split will split them vertically. So vertically we got two matrix or two array. Okay, and if we want to get three, so this way we pass just number of split that we want, whether it is v split or h split. Okay, so here what we are doing is, now this is the interesting one, we are passing a list inside that, and we are saying that split that 6 by 8 matrix into 3, 5 and 6. So what here will happen, the first split will be from 0 to 3, right? Let's say what we have is, we have 25, 74, 78. So it has taken first, second and third column. Okay, right? But since we are not we are doing h split, so it will take only horizontally. So first, second, third value will be our first array, then second will be our fourth and fifth, because the index is end here. Now the next one is fourth, and 4 to 5, then it will take fourth and fifth column from here. Okay, so second split will be our fourth and fifth, and the next will be our sixth, right? Next is, normally fifth is done, next is our sixth. So basically these are ending uh, splits value. Okay, so now it will take 6, but we have two more columns here to be splitted, so numpy will automatically get them and make a separate array for them. So let's take one more example. What we have, let's say this is our length. So length is our 4 matrix. How many times it has splitted? 1, 2, 3, 4. So we have printed the length as well, right? So this was nothing but, we can say we are doing slicing here in more simpler terms, right? So this is how we do that. And what let's say take one more example. This is more precise. So here we are doing slicing for 0, 1, right? So 0, 1 we have done that, then 2, 3, 4, 5, 2, 3, 4, 5, then 6, 7, then 6 and 7th index we have done the split here. Again we are printing the length uh, 2 of 6. Okay, if we are passing just two matrices, so it will give 3 length. How? From 0, 1, 2, then 3 to 5 will be one more, and from 6 is the last, so 6 will be our last split value. So now we have a row split also. So as we done column split, we can do row split. So what it will do is, first it will return two columns, sorry, two rows, then one row, that is third row, then 4 to 5th rows, and then our 6th rows as at last. So it has given the same here, right? And one thing we need to know, that we should remember all the split numpy object are sitting inside a list. Okay, these are always inside a list. So again here we got the 4 splits in vertically, so this has given the 4 split here. Now let's see, we have 2D stack. So basically what happens generally, we use 3 dimension. So where if we are doing head stacking, other 2 dimension will remain same. Okay, so this is obvious. And there should be row and column, they will remain same with their depth changes. For example, we have taken a nice example here, a book with 10 pages and another book with 20 pages is taken. When we stack those two together, row and column remain same, but depth become 10 plus 20, that is 30. And that is how our h stack, or we can say, works in one dimension while their dimensions get changed. Okay, let's see how it works. So we have taken one A range, right, from 0 to 11, and we are converting them into 3 by 4 matrix, right. So next what we are doing is we are again taking a range from 20 to 37 and reshaping that. Okay, so we got 3 by 6 matrix. But how will it work if we are using h stack here? Okay, so for h stack we have passed a tuple inside it, that is our uh, 3 by 4 matrix and 3 by 6 matrix, right. So it will give the shape of this. So shape is basically 3 rows and 10 columns. Okay, and we just printing this list. So using h stack we can pass the two different no matrix in a tuple. Okay, so now what I'm doing is, if we have a 6 by 4 matrix from 0 to, let's say, a 23. Okay, and if we want to perform now our vertical stack with 3 by 4 matrix and 6 by 4 matrix, so it will looks like this. Our 3 by 4 matrix and 6 by 4 matrix. So what the v stack will do is that will vertically align all those element. So now let's define a variable that is n4a. Basically it is one dimension and ranges from 0 to 3. Okay, now again let's define one more variable that is n4b, ranges from 10 to 13. Okay, and if we print both of them, that right. And now what if I want to do the column stack here? Okay, so again we are passing tuple into column stack. Okay, and if we print that, so what it will do is it will read 0 from here, 10 from here. Okay, to make one column, because we'll get two columns here, right. Then 1 from here, 11 from here, then 2, 12, and 3, 13 respectively, and will make one stack for us. So these are called our 2D stack.